Hello viewers, I am Maitli. Today we are going to see 11th CBSE Maths Introduction on Trigonometry. This is an introduction video. I'll go a recap of 10th and also the 11th introduction. Here, trigonometry deals with the right angle triangle. So in a right angle triangle, other than right angle, there are two acute angle. It can be anything. The acute angle can be on the base or on the top. If this is theta, the side opposite to it will be your opposite side, and hypotenuse, we know that 90-degree opposite will be your hypotenuse side and this is your adjacent side. The same way, if theta is here, it is your opposite, adjacent and hypotenuse. By writing Osha Chota, we can find sine, cos, tan. That is taking first three, we know that if this is sine, this will be opposite by adjacent. If cos, before that and after that will be your numerator and denominator. That is adjacent by hypotenuse. For tan, it is opposite by adjacent. So we can write all the three trigonometric ratios: sine, cos and tan. Cosecant, secant, cot are the reciprocals of sine, cos and tan. For sine, it is opposite by hypotenuse. The reciprocal of cosecant is sine, so it is hypotenuse by opposite. For cos, the secant is reciprocal, so it is hypotenuse by adjacent. For tan, cosecant reciprocal of cot will be your tan reciprocal, that is adjacent by hypotenuse. For S, C reciprocal, for C, S reciprocal, remember in that way. So your cosecant will be 1 by sine, your secant will be 1 by cos, your cot will be 1 by tan. For tan, we can also write it as sine by cos. Only then, if we in this sine by cos, hypotenuse gets cancelled and it will be opposite by adjacent. That is the reason why tan get opposite by adjacent. The same way for cot, it is the reciprocal of tan, so it will be cos by sine. So cot we can write it as cos by sine. The table we have learned even this in last year portion. This you know better. We can find the sine by taking root of 0 to 0, 30, 45, 60, 90 are there. If we take this 0 and the last one to be the 1, the middle will be your half, and in between 0 and half will be your quarter, that is 1 by 4. In between half and 1 will be your 3 by 4. If I take root of the numbers, I'll get 0, half, 1 by root 2, root 3 by 2, 1. The reverse of sine will be your cos. So this is 1, root 3 by 2, 1 by root 2, 1 by 2 and 0. For tan, as I told before, the numerator of the sine by the numerator of the cos. In the first we have told, no, it will be the numerator of the sine by the numerator of the cos. So here also numerator by numerator. So 0 by 1 will be 0. 1 by root 3, 1 by 1 will be 1, root 3 by 1 will be root 3, 1 by 0 is not defined or undefined. For cosecant, it is the reciprocal of sine will be your cosecant. So 1 by 0 by 1 will be not defined, 1 by 2, the reciprocal will be 2. So root 2 here and 2 by root 3, 1. Similarly for secant, it is the reverse. And for cot, the reverse of the tan will be your cot. So this table we have learned this in 10th standard. Now we are going to the 11th standard portions. In 11th standard portion, we are going to see some measures of angle. We usually call that to be theta. It will be of degree. But here there are two way of measuring your angle. That is, one is degree, the other one is the radian. So here we are going to see measures of radian. The measures of degree you know better, we have learned that in the lower classes. Here we are going to see the measures of radian. 2 pi is called as 360 degree. 2 pi radian will be equal to 360 degree and pi radian equal to 180 degree. So pi radian will be equal to 180 degree. Okay, I'll just give you one degree equal to pi by 180 radian. I'll give you an int to degree to radian. To change from degree to radian, we need to multiply degree into pi by 180. So remember this, just multiply the degree into pi by 180 to form a radian. For radian to degree, just multiply the radian into 180 by pi. If you multiply radian into 180 by pi, we will get the value of a degree. Remember this will be very easy. Degree to radian, multiply the value into 180 by pi. Similarly, radian to degree, multiply the value of radian into 180 by pi. So your pi radian is equal to 180 degree. We will be using this, or we can use this for unitary method. If you want to do in a unitary method, you can use this formula, or this will be very simple. You can directly find anything, degree to radian or radian to degree. You can directly multiply the number so that it will be very easy for you to finish the sum. We'll move on to the area of the sector, which we learnt in the smaller classes. Area of the sector is nothing but theta by 360 into pi r square, right? A is equal to theta by 360 in the pi r square. When theta is a degree measure, we can use this formula which we have learnt in smaller classes. But here, if it is a radian measure, then your formula will be equal to r square theta by 2. Your formula will be equal to r square theta by 2 when theta is a radian measure. Now we'll see the length of the arc. For length of the arc, this formula we know better, which we have learnt in lower classes. L is equal to theta by 360 into 2 pi r. If the theta is a radian measure, then your L is equal to theta r. This formula you will be using this year. Even this for area will be using in the 11th standard. When theta are in radian measure, then L is equal to theta r. Now the general identities you know. Last year we studied sin square theta plus cos square theta equal to 1, 1 plus tan square theta equal to secant square theta. Similarly, 1 plus cot square theta equal to cosecant square theta. This three formula we have learned in lower classes. Now, one small information is that 1 degree equal to 60 minutes. 1 degree equal to 60 minutes. The minute symbol is this. Degree symbol, you know, one small 0, but here minute symbol is one small slash. So 1 degree equal to 60 minutes. 1 minute equal to 60 seconds. 60 seconds, this we know in clock. 1 minute equal to 60 seconds. For seconds it is double dash. So remember, this is the symbol for a minute and for a second. Now we'll move on to a next level of your trigonometric for introduction. This is very important. This will be, the sum will deal with this. Now for sine. If I take a graph, this will be my 0, this will be my 90 degree, this line will be my 90, and this line will be my 180, and this will be my 270. Again this will be my 360. So we know the graph of this and we know the values of these lines. Okay, then let us remember this by all silver teacups. So all silver teacups, you know, this is the first quadrant, this will be your second, your third quadrant and your fourth quadrant. Here all silver teacups. For what this all silver teacups is that, here this I told you this is for sine. Here all means we need to write all signs, all ratios. Here the sign will be positive. So for sine, tan, cos, cosecant, secant, cot, for everything the sign, if this comes in this quadrant, then it will be a positive value. If this travels, this theta travels in this area, it will be of positive value. So if all values will be positive. Here sine and the reciprocal of a sine, that is cosecant. Sine and cosecant will be positive. The rest, all the ratios will be negative. Here sine and cosecant are positive. The rest will be negative. Here t means tan and cot. Tan and its reciprocal, that is cot. Tan and cot will be positive, the rest are all negative. Here C means cos. Cos and its reciprocal secant will be positive, the rest are all negative. So here everything is negative. Here sine and cosecant is negative. Here tan and cot is negative. Here cos and secant is negative, the rest are all positive. We have learned complementary angles in your last year, right? Sine 90 minus theta equal to cos theta, cos 90 minus theta equal to sine theta, tan 90 minus theta equal to cot, cot 90 minus theta equal to tan theta, secant 90 minus theta equal to cosecant theta, cosecant 90 minus theta equal to secant theta. This complementary angle we know we are very much thorough with this. Now if theta comes in this area, we know it is 0 plus theta. This can be also written as 90 minus theta. This is totally 90 minus theta. This can be also, if theta comes, if there is one angle over here, this can be also called as 90 minus theta. So this region is 0 plus theta or 90 minus theta. Even this region, this is 90 plus theta. If there is one line and if this is the angle theta, then it is 90 minus plus theta will be here, or 180 minus theta. If always it travels in a anti-clockwise direction, it will not be in a clockwise, it will be in anti-clockwise direction. So theta will, your angle will travel in a anti-clockwise direction. If theta comes here, then it will 90 plus theta or 180 minus theta. If theta comes in this area, it will be 180 plus theta, because theta travels like this, so it is 180 plus theta or 270 minus theta. The clockwise direction will be negative. Yeah, it is 270 plus theta or 0 minus theta. It can be said 360 minus theta or 0 minus theta. Both are same, because here it is 0 or 360. Now I'll just give you one hint. We need to learn this table, but it is not necessary for you to mug it up. This table we are going to use in the sums, but according to me, no mug it up. Just we can follow this to find this. 90 plus or minus theta, that we have learned in complementary angles is 90 minus theta will be for cosecant, 90 minus theta will be secant. So we are changing for a complementary angles. Remember that 90 plus or minus theta or 270 plus or minus theta, it will be of complementary angles. That is, we are going to change of complementary angles, that for 90 plus or minus and 270 plus or minus. For 0 plus or minus or 180 plus or minus, we need to write the same. Same in the sense, if it is secant, then secant only. If it is cosecant, the cosecant only. You will not change any ratios. Here, for complementary will be changing. To remember that, take 9 and 27 are odd numbers. For odd numbers we need to change, just for remembering, it's not anything with the odd or even, just for you to remember. 9, 27 is odd. For odd number we need to change to complementary angle. Here it is 0 and 18 are even numbers, so we will write it as same. So just remember, in this way it will be easy for you to understand. And for this, it depends on the angle, it depends on the sign of the quadrant and the complementary and the same. So this table, no need to mug it up. If you know this, we can easily mark this. Now we'll move on some identities which we are going to deal this year. New identities. Here it is double angle identity. Double angle means 2a. If 2a comes, what all the formula for 2a? Sin 2a equal to 2 sin a into cos a. So sin 2a equal to 2 sin a into cos a. It can also be, sin 2a can be also written as 2 tan a by 1 plus tan square a. So it is 2 tan a by 1 plus tan square a. When sin and cos is given, we can use this formula. If tan is given, we need to use this formula. Next one is cos 2a. Cos 2a equal to cos square a minus sin square a, or 2 cos square a minus 1, or 1 minus sin square a, or 1 plus tan square a by 1 minus tan square A by 1 plus tan square A. When the value, it depends on the value given by cos square A, sin square A or tan square A. This two formula is just a change of this. While I can use 1 minus cos square A can be written as 1 minus sin square A. If I get this formula instead of sin square. If I use 1 minus cos square A, just multiplying the minus sign inside and solving, I get 2 cos square A minus 1. Now we'll move on to the tan 2A. Tan 2A is nothing but 2 tan A by 1 minus tan square A. So 2 tan A can be written as 1 minus tan square A. So these are the formula for double angle identities. There is no separate heading for you in the reader, but I have just given you a correct heading for each and every formula. Now it is called a power reducing identity or a reduction identity. Power reducing means we are writing that to be square. So sin square A can be written as 1 minus cos 2A by 2. So we know that sin square A equal to 1 minus cos square A, but here, so this is here it is the power reducing, so 1 minus cos 2A by 2. Here cos square A equal to 1 plus cos 2A by 2 and tan square A equal to 1 minus cos 2A by 1 plus cos 2A. Here it does not deal with any sign ratio, it deals only with the cos ratio. So these are the power reducing identity or reduction identity. Next we will move with triple angle identities. For triple angle identities, it deals with 3x, okay. Sin 3x is equal to 3 sin x minus 4 sin cube x. Cos 3x is equal to 4 cos cube x or 4 cos cube, if there is no theta here, so 4 cos cube x minus 3 cos x. Tan 3x is equal to 3 tan x minus tan cube x minus 1 minus tan square x. Where are all the formula necessary? If it's 3x, we need to use this formula. If it's 2x, we need to use double angle formula. Now half angle identity. Half angle identity equal to sin A equal to 2 sin A by 2 into cos A by 2. This can be, sin A can be also written as 2 tan A by 2 by 1 plus tan square A by 2. Cos A equal to cos square A by 2 minus sin square A by 2, or it can be also written as 2 cos square A by 2 minus 1. These are nothing but the half angle are nothing but the angle we dealt with double angle identity. Just by dividing A by 2, here it is 2A, by dividing A, instead of A, 2A we are writing A by 2. That's all. The rest of the formula, it is same as the double angle identity. There is no anything different in half angle identity. It is same as the double angle identity, but there it is 2A and here it is A by 2. We'll move on to the next level of sum to product. Here sum to product, in the sense, these are very important. We usually do sums dealing with this formula, dealing with this identity. Sin A plus B equal to sin A cos B plus cos A sin B. Sin A minus B is equal to just changing the sign. For sin and cos will include, if this sin and cos, it will be cos and sin, and A and B in each case. For cos doesn't have anything with the other ratio, so it will have cos, sin. So AB. And cos, there is a change of the sign in between. If here it is plus and here it will be minus. If here it is minus, here it will be plus. So for sin A plus B, sin A cos B plus cos A sin B. Sin A minus B equal to sin A cos B minus cos A sin B. For cos A plus B, cos A cos B minus sin A sin B. That will be change in the sign. For cos A minus B, cos A cos B plus sin A sin B. So we have a formula for tan and cot. I have written it here. I'll show you. For tan and cot, tan A plus B equal to, same way we need to put the same sign plus on the top. So tan A plus B by 1 minus tan A into tan B. Here into. Now tan A minus B equal to tan A minus tan B by 1 plus tan A tan B. For cot, it will be of reciprocal and changing of sign. See, cot A plus B equal to cot A cot B minus 1 by cot A plus cot B. For cot A minus B, cot A cot B plus 1 by cot A minus cot B. So remember this, the sum to product tan and cot formula. Now we'll move on to the sum product to sum. This is just the formula. We can derive it from the top, that is sum to product. We have already written no sin A plus B. From there we can derive this formula by adding and subtracting the top. We can find this formula. So no need to mug it up. Just have a look so that we can derive this formula by solving on the top, that is sum to product B. If we solve this 2, we get the another formula. Now just have a look of the formula. Sin A cos B is equal to half into sin A plus B plus sin A minus B. Similarly, cos A into sin B equal to half sin A plus B minus sin A minus B. Cos A cos B equal to half cos A plus B plus cos A minus B. Sin A sin B equal to half cos A minus B minus cos A plus B. No need to mug it up, just have a look. Here, sum to product the same way. It's just a derivation of the formula. Sin A plus sin B equal to 2 sin A plus B by 2 cos A minus B by 2. Sin A minus sin B equal to 2 cos A plus B by 2 sin A plus B by 2. Cos A plus cos B equal to 2 cos A plus B by 2 cos A minus B by 2. Cos A minus cos B equal to 2 sin A plus B by 2 sin A B minus A plus B minus A by 2. So there is a quite different in this. We can also take a minus sign outside and write it as sin A minus B by 2. Anyway you can write, but be careful in cos A minus cos B. There is a quite change in other 3. So it is 2 sin A plus B by 2 into sin B minus A by 2. We'll move on to the next general solution. So this is the last identity for you. With this, the trigonometry ratio is over. Now we'll see general solution. Sin A is equal to 0 gives A is equal to n pi where n belongs to z. This we need to write everything for general solution, otherwise you will lose mark. Sin A equal to 0 gives A equal to n pi where n belongs to integers. Now cos A equal to 0 gives A equal to 2n plus 1 into pi by 2 where n belongs to z. Sin A equal to sin B implies A is equal to n pi plus minus 1 power nb where n belongs to integers. Cos A equal to cos B implies A is equal to 2n pi plus or minus b. Here everything A is equal to, you need to get b. In the cases of equal to, that is sin A equal to sin B, cos A equal to cos B, but here it varies. If you multiply this inside, you will get this. So it's 2n pi plus or minus b where n belongs to integers. Similarly, tan A equal to tan B implies A equal to n pi plus b where n belongs to integers. Tan A equal to 0 gives A equal to n pi and n belongs to integers. These are the general solution. That's all with the trigonometric formulae for this year. Thank you.